Okay, so this one, path conditioning, I think this is the easiest one to understand. It is quite simply how much FEC we add to how much overhead we add to the link. The more FEC you add, the closer you get to 100%, the better we deal with packet loss. Or delayed packets. It actually also, FEC works for delayed packets as well. Like if I have 2 packets going, and one of them, my primary link is this side, and my next best one is this one. If this link gets impaired and has 1,000 milliseconds of wait time for 10 seconds, those FEC packets are going to get to the other other side, and they're going to fill in the gaps. These guys are going to arrive. They weren't lost per se, but the FEC packets will fill in the delayed gaps. So it's not just packet loss that FEC takes care of. It also handles large delays in some cases. So this control gives you the minimum and maximum for FEC. So what's the minimum amount of FEC of parity that you'll add? What's the maximum amount? The silver peak will adjust between the two. So it will, if there's no loss, no perceived loss on the underlay, then FEC will be at 0 or at the minimum. Like in this example here, the minimum is 50 and the maximum is 100. So if we're just steady state cruising along, no loss, we're going to be adding 50% parity to the second best link in the form of FEC. If a lot of loss starts up, it will gradually ratchet up from 50 to 100 and try to compensate for that loss. So yeah, if you set both of the sliders to 100, you have HA mode. Same thing, 1-to-1 FEC, 100% FEC. If you set them both to 0, then you have high efficiency mode. FEC is turned off, essentially. If you have only one tunnel available between 2 peers, it doesn't matter what you set in the path conditioning setting. You set it to 100 and 100, it'll still only do 20. This is the packet reorder wait time. This has to do with when we decide to report loss. So if you see when you see loss, a little loss spike in the show up in the various charts throughout the product, that means that this timer expired. Like we waited longer than something and decided that it was lost. Interestingly, it's possible to have a packet that is just highly delayed. So like let's say that I suddenly have 800 milliseconds of latency. The packet reorder wait timer will expire, and we will count that as loss, even though the packet shows up later. And that will appear as light blue as recovered packets. So this timer has some interesting meanings. Like if you set the max, let's say you set the min to 200 and the max to 200. You set the wait time really high. What that will do, it's not a good thing usually, is if you drop a packet, the silver peak will it will wait up to 200 milliseconds to see if the FEC packet's going to arrive, and it will delay. It will cause you'll see large latency spikes when you drop packets. So you got to be a little careful with this timer. The default, and what we've used for years and years, and which has worked in most cases, is 0 to 100. And if you look back at all the built-in modes like HA and HQ and HT, the packet reorder wait time for all those is 0 to 100. So a good example would be like voice. Voice doesn't really care about loss, counter to what you might hear, like Zoom, Discord, even Skype. All these things, they can suffer up 10% or more packet loss and still be able to talk to somebody pretty well. So you might make an argument that setting that packet reorder wait time lower, sliding the minimum down, would improve real-time traffic. Whereas TCP-based stuff, high throughput applications that need to retransmit, they do not handle loss well. So it's better to wait a little longer and see if the FEC packet's going to show up than it is to give up and mark the packet as lost. The FEC wait time, it sounds important, but it's kind of not. It has to do with when there's a small amount of traffic, a trickle of traffic on the network, how long we wait. I think in most cases you're just going to leave this one alone.